My name is Prasad Arwade. I am from Annasaheb Dange College of Engineering and Technology, Asta, from Computer Science Department. My topic of presentation is transportation problem by Vogel approximation method, that is VAM method. Transportation problem. Transportation problem is a special kind of linear programming problem in which goods are transported from a set of sources to a set of destination subject to the supply and demand of the sources and destination respectively, such that the total cost of transportation is minimized. Types of transportation problems. Balanced. When both supply and demands are equal, then the problem is said to be balanced transportation problem. This is the ideal situation in the transportation problem. Unbalanced. When the supply and demand are not equal, then it is said to be an unbalanced transportation problem. In this type of problem, either a dummy row or dummy column is added according to the requirement to make it balanced problem. Then it can be solved similar to the balanced problem. Methods to solve the transportation problem. First is northwest corner cell method. Next is row minimum method. Another one is column minimum method. Least call cell method, and last one is Vogel's approximation method. This is the basic structure of the transportation problem. In the above problem, D1, D2, D3 and D4 are the destinations where the products or goods are to be delivered from different sources O1, O2 and O3. Ci is the supply from the source OI. Di is the demand of the destination Dj. Ci is the cost when the product is delivered from OI to the destination Dj. This is the example of transportation problem where D1, D2, D3, D4 are destinations and O1, O2, O3 are sources from which products or goods are supplied, transported. Supply values are 300, 400 and 500, and demand values are 250, 350, 400 and 200. So supply and demand are equal, that is 1200. So this is a balanced problem. This is the problem. Here supply is 1200 and demand is also 1200. So it is a balanced problem. So we can start to solve problem by VAM method. First step is to find out the row difference. Row difference can find by first find the least value and then find the second least value and take the absolute difference of these two least values and write it in the corresponding row difference. In row O1, 1 is the least value and 3 is the second least value, and their absolute difference is 2. Similarly, we can do for row O2 and O3. For each column, uh, also same process is repeated. Here we can see that for column D1, 2 is the least value and 3 is the second least value. Their absolute difference is 1. Similarly, for column D2, D3 and D4, we can perform, and their row differences are respectively 2, 2 and 2. Next step is to find maximum penalty. The value of row differences and column differences are also called as penalty. Here maximum penalty is the 3 from row 2. Now find the cell with the least cost in row 2 and allocate the minimum among the supply of the respective row and the demand of the respective column. 2 is the least cost in row 2. Demand is smaller than the supply, so allocate the column's demand, that is 250, to the cell. Now the demand is fulfilled of the column D1, so cancel the column D1. From the remaining cells, find out the row differences and column differences. because column D1 is get cancelled, do same process for D2, D3, D4 column, D2, the D3, D4 column. So the row differences are 3, 1, 1 and column difference is 2, 2, 2. Again select the maximum penalty, which is 3, corresponding to row O1. The least cost cell in row O1 is O1 D2 with cost 1. Allocate the minimum supply and demand from the respective row and column to the cell. Cancel the row because supply becomes 0. So row O1 get cancelled. Again follow the similar process for calculating the row and column differences. Now select the maximum penalty, which is 7, corresponding to column D4, and the least cost cell in column D4 is O3 D4 with cost 2. The demand is smaller than the supply for cell O3 D4, that is 200, which can be fulfilled by its corresponding supply, which is having 500. So the demand is fulfilled, so row D4 get cancelled. For this new updated problem, again calculate the differences for remaining cells. Now from new differences, the maximum penalty is 3, corresponding to column D2. The cell with the least value in D2 is O3 D2. That is cost with the 3. Allocate the minimum of supply and demand to it, that is 50, and demand becomes 0, so cancel that column. Now there is only one column, that is D3, so we here not calculating the difference, and according to it select the cell with the least cost, that is 3, and allocate the appropriate value to it, that is 250, because its demand is 400, and all demand cannot be fulfilled by its supply, because 250 supplies only remains. Due to it 250 is allocated to it, and supply becomes 0, so row O3 get cancelled. Now there is only one cell, that is 5 is remain in the problem, so allocate the uh, appropriate demand and supply to it. 150 is allocated to it, so row supply of row O2 is also 0, and demand of column D3 also becomes 0, so cancel the row and calculate the transportation cost. No balance remains in this problem. Supply and demand get allocated according to the need, so multiply the allocated value of the cells with their corresponding cell cost and add all to get the final cost, that is 1 is multiplied with the 300, 2 is multiplied with the 250, 50 is multiplied with the 3, 150 is multiplied with the 5, 3 is multiplied with the 250, and 2 is multiplied with the 200, which gives the final transportation cost is 2850. This is the final transportation cost, and it is all about all information about the transportation problem by using VAM method. Thank you.